Welcome to Geometry for AP. This is the end of the year worksheet day 4. This video actually worked for day 4, day 5, day 6, and day 7. They'll all be doing with the same concepts, just we will be working with the different figures as they get more complex as the problems move on. So during this worksheets, we'll be graphing figures on a coordinate plane. Once we've found the figure, then we will find the area of that figure on the coordinate plane, and then we'll revolve that figure about an axis to form a solid, and then we'll find the surface area and volume of that solid. And these will be, some will be simple solids like cones or cylinders, and some will become more complex with frustrums or different cylinders with holes or different parts removed. So if we were to graph a rectangle on a coordinate plane, which we had done on worksheet 2 or 3, and we took that rectangle and we rotated it about this or revolved it about this axis. So we do a revolution. We get what's called here a cylinder, and so we can use the graph to find our radius here and our height so that we can find the surface area volume of that figure. If we were to graph a triangle on a coordinate plane, and we get this triangle, and we were to revolve it about this axis here, like this, then we would get a three-dimensional solid, where we have a cone, and we have a radius here, and we have the height for that cone, and so we can find the surface area and volume of these figures. As these figures change, and so here's another right triangle, when we revolve this right triangle about the y-axis here, we get a cylinder with a cone removed, and so we would need to find the surface area volume of that. So a cylinder's surface area would be, 2 pi RH plus pi r squared, which is the circle bottom, plus the pi RL, which is the lateral area of the cone. And if we were going to do the volume, it would be the volume of the cylinder, which is pi r squared h, minus the volume of the cone, pi r, 1/3 pi r squared h. And so then we would have the volume of that figure. Or like here, when we have the rectangle, but this time it's away from the axis and we spin it, we get that figure that looks a little bit like a toilet paper roll. So if we want to do surface area, remember that it is the 2 pi RH plus the 2 pi RH, because that is the lateral area of the inside cylinder and the lateral area of the outside cylinder. Plus, there are the bases, which there are 2 of them, and that's pi r squared minus pi r squared. Now remember that this radius and this radius are different, and this radius and this radius are different. So the r1 is the larger radius, and of course the height is the same for all of them. Down here we have a frustrum with a cone hole, and so the formula that would be a lot more complex. I'm not going to write it here because we're going to do a lot more work of that during class and stuff like that. So we did do frustrum in video 2, so this would just be some adding and subtracting of different things. So in the volume of this one, we would actually take the volume of the frustrum and subtract the volume of the cone hole. But again, some of the numbers are very easy to get for these, because if you graph this on a coordinate plane, you can easily count the radius here, you can count your height of your cone, your height of the cone that you remove, and so you can get all these different numbers very easily from the graph, but you got to make sure you graph them correctly, and that's kind of where we're going. So like here's a trapezoid. When this trapezoid is spun about this axis here, we get a cylinder with a cone on the top and a cone on the bottom. Over here, here's a different trapezoid, and we spin this one, we get the frustrum, because this is the top cone is being cut off of this figure, so that's a frustrum there. So depending on which direction you spin the trapezoid, you could get very different and interesting figures. So here's our first problem. So we're going to graph x is equal to 2, x is equal to 5, y is equal to -1, y is equal to 5. So if you want to pause the video and graph those on a piece of graph paper, that'd be great, so that you can follow along with this problem. Okay, so now that you have those graphed, they should look like this. And so we have this figure, and we're going to revolve this figure around the y-axis. So I always like to draw this little symbol here so that it reminds me which way I'm going to spin this figure, and it also tells me where the center of my revolution is going to be. Okay. And so now that we have this figure, when we revolve it about this, here we can see the cylinder with the cylinder hole that goes through it. And I can easily count all my different numbers. So like here, the radius is 2, and this radius right here is 5, and the height is 1, 2, 3, 4, 5, 6. The height be equal to 6 for both of them. So I have every number I need here to do my formulas. So now when we go into here, here's our surface area formula. We get 2 pi RH, we got the first radius, second radius. And so you're going to plug that information off of the graph, plug that information in there, and solve for the surface area. So take a minute to do that. Pause the video to do that, and then turn the video back on when you're ready to go. Okay. So if you have that done, here is the answer you should be getting. You should get 126 pi units squared. And so now that you've done that, you can double check your work. If you get an error in that, bring that back to class and we can look at it and see what you've done wrong and point things out to you. Now the volume of this figure is the volume of the big cylinder minus the volume of the little cylinder. And so when we do those volumes, we'll get an answer in units cubed. So pause the video, go get that information. Remember that the radius here is 2, and the radius for the other part is 5, and the height was 6. Okay. And so now we get to here, let's check your volume, see how you did on your volume. Your volume would be 126 pi units cubed. Now, I know it was 126 for the surface area. These are different kinds of units. They don't mean the same thing. That just happens to be that those numbers come out the same. Does it happen all the time? No, it just happened to on this problem. So be careful of coincidences. All right. All right, so here's our next problem. Okay. Graph this figure on the coordinate plane, pause video, graph it, and then turn the video back on when you're ready to move forward. Okay, so let's graph this one. So when we graph this figure, this is what we get this time. And it says here we're going to revolve around the y-axis, so we're going to spin this way. And I need you to understand that this is the figure I'm looking at this time. So not this little top part, that's not part of it, it's just between those lines. And so when I revolve around this axis here, I'm going to get this shape shaded. And so here I get my whole cone. So I've got my whole cone here in blue. And then I've got my top cone, which is right here in the red part. And I can easily see that my radius right there is 2, and my height is 1, 2, 3, 4. My height from here to here, height is 4. If I go look at my big cone, my radius is 3, and my height is 1, 2, 4, 5, 6. And so my height here is 6. Remember that in these figures, we're going to need our lateral area also, so we're going to need our slant height. So if I was to do my Pythagorean theorem here, this would be 2 squared plus 4 squared equals my slant height squared. So that's 20. So square root of 20 is equal to L, which is going to be 2 square root of 5 is my slant height there. If I go over to my blue one, right, we're going to have 3 squared plus 6 squared equals L squared. So that's 36 plus 9, so that's the square root of 45 equals L. So that's 3 square root of 5 is my L. And so I have all the numbers I need here. Okay. And so once I have the numbers I need, I want to find the surface area. And here's your formula for surface area. So you can pull that information off and plug it into the surface area formula and work out and find your surface area of your frustrator. Take a minute to use those numbers from this page right here on this video, or on this formula. All right, now here is the volume formula. So we have those numbers from before. I'm going to go back to those numbers right there. There's all your radiuses and your heights. And so I'm going to take those numbers and I'm going to plug them into the volume formula. Remember that the volume formula, the radius 1, and I could say that actually that this is a different height than this one, because those are different heights of cones. So R1 and H1 are the larger ones. That's the large cone, and the R2 and the H2 are from the small top piece that you cut off. When you've gotten those formulas done, finish your work and keep going with your video. Okay, and here are your two answers that you should have. Remember that this one is going to be in units squared, and this was going to be units cubed. If you have problems working the formulas, then you can bring your work in and we can look at it. Don't erase everything. Make sure you have it down so we can look at it. Always have something, even if it's wrong work. It gives us something to work with. All right, so here's another problem. So pause the video, graph it, revolve it about the axis, about x is equal to 0, and then get your surface area and volume. So here's your graph picture. Revolving about the x is equal to 0. X is equal to 0 would be this line again, which is this axis. And so x is equal to 0 is a vertical line. When we spin it around that, we get this picture. That is a cylinder with a cone removed. We're going to find the surface area and volume. So here's your surface area formula. What would our radius here be? I go back over my graph. I can see my radius is going to be 2. My height is going to be 1, 2, 3, 4, 5, 6. So my height is 6. That makes this radius also 2. The height in there is also 6. And I might end up needing that slant height for that. So I'm going to use 2 squared plus 6 squared equals L squared. So that's 36 plus 4. So that's square root of 40 is equal to L, which is 2 square root of 10 equals my L. And so that gives you all the numbers you need in there. So make sure you finish your workout, show all your work. Once you've done the surface area, here's the volume formula. We're going to take the volume of the cylinder. We're going to subtract the volume of the cone to get what's left. All right. You're going to need to be able to show all the numbers and work plugged into that in order to get credit for your video notes. And so then here are the two answers that you should have. So 28 pi plus 4 pi squared root of 10, and then 16 pi is the volume. Again, if you have problems with these in the video notes, bring them back to class and we can look at your work and see what your numbers you got and where the problems are. So here's some things to remember, okay? This video works for 4 through 7 as it goes through the process of some of those formulas. Worksheet 3 has 3 problems doing a little bit of everything, surface area and volume on each one. Figures aren't always too complex in the first one. 5 is just finding volume of all the figures. Get you some practice with some complex figures for volume. Worksheet 6 is finding a surface area and volume for figures, but it's like you're using the same figure over and over again to do different rotations and stuff. Worksheet 7 is finding surface area and volume of very complex figures. I actually give you the picture of what it looks like for worksheet 7 to help you with seeing things. Some helpful tips. Make sure you graph your lines correctly, especially your vertical and horizontal lines. Make sure you solve for y correctly. In other words, your slope will be backwards and your figure will be totally wrong. Make sure you're revolving the figure about the correct axis or line. Double check that. Make sure that's the right one. Write your formula out. I want to see a formula every time. I want to see the information pulled out of the picture and put into the formula. You should draw a picture of whatever the shape is. Do your best to draw a three-dimensional picture. It'll help you to develop the formula a lot better. And that is just about everything that you need to be able to do. So keep watching this video over and over again if you have problems. That way you can go through the processes more. Okay? And so good luck.